Look closely at this satellite image of the moon. Frozen in time. You can still see the tracks in the dust and the descent stage of the lunar module from the last time humans walked there. That was Apollo 17. Over 50 years ago. The finale of an era that put humankind on another world. But now, a new chapter is beginning. Nations and private companies are in a concerted push to return. So why has it taken more than half a century? And what's different about this new era of lunar exploration? I'm Rana Asif, and this is the Deep Dive. To understand today, we rewind to the 1960s. The first space race was a defining project of the 20th century, driven by the competition between the United States and the Soviet Union. It was a powerful demonstration of technological and ideological capability. The Soviet Union scored historic firsts. The first satellite, the first animal, the first human in orbit. But in 1969, America achieved the seminal goal, landing humans on the moon. By 1972, 12 astronauts had left their footprints in the lunar dust. And then, the mission stopped. The Apollo program was phenomenally expensive. With its primary geopolitical objective achieved, political will and funding shifted. Focus turned to orbital platforms like the Space Shuttle and the International Space Station. The moon faded from the immediate horizon, but the dream of returning never died. And in the 21st century, new catalysts emerged. A major one, the rise of other spacefaring nations, most notably China. China methodically built a robust lunar program, landing its change rovers where no spacecraft had gone since the 1970s. They openly stated lunar exploration as a symbol of national capability and scientific stature. This, alongside a revolution in commercial spaceflight, reignited American ambition. The result is NASA's Artemis program, but unlike Apollo, Artemis is built on international partnerships and relies heavily on private companies like SpaceX and Blue Origin to build landing systems and hardware, a strategy aimed at innovation and controlling costs. However, this complex, multi-stage approach means progress is deliberate. Safety standards are incomparably higher than in the Apollo era. The first crewed landing is now targeted for no earlier than 2026 or 2027. So why go back? This time, the goal is sustainability. The focus is the moon's south pole. Why? Data indicates deep, permanently shadowed craters there contain water ice. Water is the key. It can support life, providing drinking water and breathable oxygen. When split into hydrogen and oxygen, it becomes rocket fuel. This concept using local resources is called in situ resource utilization, or ISRU. The moon could become a proving ground and a fuel depot for deeper space exploration. The vision is permanent outposts. And the moon may hold other valuable resources, like helium-3, a potential fuel for future fusion reactors. While extracting it remains a monumental technical challenge. It illustrates the long-term thinking. The moon as a platform for scientific and economic activity. This new lunar endeavor isn't a simple two-nation race. It's unfolding within two broad, overlapping frameworks of international cooperation. The US-led Artemis Accords, signed by dozens of nations including India, Japan, and European countries, set principles for peaceful lunar exploration. Concurrently, China is leading the International Lunar Research Station project with partners like Russia. Both initiatives aim for sustained lunar presence. This creates a new dynamic in Space One where establishing a permanent foothold, with the infrastructure and resource rights that may imply, is a primary objective. The first space race was about achieving a mission spectacular short-term feat. The new era is about enabling activity building, a long-term, sustainable capacity in space. It's driven by a blend of scientific discovery, technological aspiration, and the age-old human drive to explore and expand our horizons. The moon is no longer just a destination. It is envisioned as a stepping stone, a testing ground for the skills and systems needed to one day send humans to Mars and beyond. What do you think? Is this new lunar push worth the investment, or should our sights be set elsewhere? Let's discuss in the comments. If you enjoyed this deep dive, please like, subscribe, and hit the bell for more content that explores the frontiers of science and technology. For the deep dive, I'm Rana Asif. Thanks for watching.